In this video, we're going to look at parabolas. Now, before we go too far in the shape, I want to go over some of the vocab that you will see over the upcoming slides. First, the actual definition of a parabola. It's the set of points that are an equal distance from this special point here called the focus and this line here called the directrix. So if I picked a point on the graph, I'm telling you that the distance from the focus and the closest distance to the directrix should be equal. All of the points that have that in common create that shape for us. The next definition we have, the vertex. This is a point on the parabola, but it's the most important one. It's the one that kind of defines where the graph is splitting into two different pieces. Many of our formulas are going to be based on the coordinates of that point specifically. Then we have the focus. This is a point that's not on the line itself for the parabola. It's kind of like it's inside of the parabola. It's always going to dictate which direction that the parabola is opening towards. So if the focus is to the right of your vertex, then it opens to the right. If the focus is to the left of the vertex, then the parabola will open to the left. And likewise, if the focus is below, it will open down. Another important component is called the directrix. The directrix is a line kind of like an asymptote. The graph itself is always going to avoid that line. So wherever your directrix is, you can also use that to say that the parabola opens away from that direction. And then the last piece is called the focal width. Now, if I was to describe the width of the parabola, you might notice that the width changes depending on when we're looking at it. So the most important width that we focus on is the one that happens right here. It's the width of the parabola specifically passing through the focus. That way, if I say it has a width of 6, everybody knows where to look at for measuring that width. So now for some rules that we'll be using when we're working with parabolas. The first one is the h and the k value that make up the vertex itself. It's very important to know that the vertex is always exactly halfway between the focus and the directrix. So some questions will not give you the vertex, but they'll give you the other two pieces. So you can plot them on a graph and find the one that's halfway between, and that'll be the location of the vertex. Some questions may give you the focus and the vertex instead, in which case you can measure what that distance is, and then as soon as you find out if it's 2, 3, 4, whatever, you can measure that same distance in the opposite direction, and that's how far away the directrix will be. So you'll be able to place that object instead. So as long as you know two of the components, you should be able to find the third by focusing on the fact that the vertex is halfway between the other two components. The variable we use for measuring the distance from the vertex to the focus, we call that p. And so since I told you that the distance there and the distance there is equal, that means this one is also p. And there's one more place that we use the distance p, the focal width of the parabola that we were talking about earlier. So this width across is going to be 4 times p. And in this example, you can see that since p is 1, that's a distance of 1, that's a distance of 1, and this width all the way across is a width of 4. My advice for this unit is to sketch the graph of the two components that they give you in the question. Use the placement of those two components to find the third one, and then measure the distances to find what p is. And the vertex, that's your h and your k value. So once you plot that point, that'll be the h and the k value for the standard form. Speaking of the standard form, here it is. Now we have two different equations for parabolas, because there's the case where the parabola is opening up or down, and then there's the case where the parabola is opening to the left or right. So some of the variables do flip around. It's helpful to know that h is always with x. No matter where the x gets moved, h is always with it. Similarly, k is always paired with y. So no matter where the y is in the equation, k always goes with it. So once you find the coordinate of the vertex, put h with x, put k with y. The other value, p, goes right here in front of whatever's on the right side of the equation, whichever variable you have there. Do note that it's not just p by itself, it's always 4 times p. So you'll always need to multiply the p that you find by 4 to get the standard form of the equation. Now the trickiest part is that sometimes p is a positive number and sometimes it's a negative number. And this depends on which direction the parabola is opening. So if we know that it's an up and down parabola, we focus on whether p is a negative number if it's opening down, or if it's opening up, it's going to be a positive number. That's what I mean by less than 0 or greater than 0. If we know it's a case where the parabola is opening to the left or right, so it's going in the x directions, then it'll be a negative number if it's opening to the left, and it'll be a positive number if it's opening to the right. Now the shape of the directrix that we looked at, that was like the asymptote type line, it will be a y equals equation if your parabola is opening up or down, and it will be an x equals a number equation if it is opening to the left or to the right. Because remember, x equals equations create vertical lines for the directrix, and y equals equations, like if I say y equals 5, that's a horizontal line at a height of 5. The vertex is the h and the k value we were just talking about, and the focal width, this number should if I say what is the width, it's always going to be the absolute value of that, but this number up front could be positive or it could be negative. So the focal width is always positive because we don't define negative distances, but in the formula, you may have a negative number on there, which would indicate that the p is positive or negative according to the rules that we talked about earlier. So what I recommend for finding the graphs of the parabolas, first, the question is going to give you two components. Draw the graph and sketch where those two components land. Next, you would want to use the fact that the vertex is halfway between the focus and the directrix to find whichever component you don't have out of the three, the vertex, the focus, and the directrix. Third, I like to measure the distance from the vertex to the focus. That's how I can figure out p. But always be careful to double check, is it going to be a positive or a negative for that distance you measure? Because that will affect the equation in the very end when you start plugging in the numbers. So let's look at some examples together. I'm going to use the black pen to mark what they gave me, and I'll use the red pen to indicate what I filled in on my own. So first they gave me that the vertex is at 3, 4. So I'm going right 3, up 4, and I'm drawing a dot. Then they gave me that the focus is 5, 4. So I'm going to the right 5 and up 4, and I'm drawing that dot. Now that I have those two components, I can measure the distance between the coordinates they gave me. This is a length of 2. Well, since the vertex has to be halfway between the focus and directrix, that means I can go 2 more in this direction, and that would have to be where my directrix lands. Now, the directrix is actually going to be an entire line, so I'm just going to do a light dotted line, kind of like an asymptote, to indicate where that object landed. So now I don't need the 2's in there anymore. Now, the next thing that's important to remember is that the parabola itself starts at the vertex, and it opens towards the focus. So I now know exactly which direction to go on this. If I want to be real precise with how wide the parabola opens, now that I know p is equal to 2, I can also say that the width right there at the focus should be 8 across. But I don't usually need to worry too much about that just for sketching the graph. But if I want to be very precise, I know exactly how wide to make the parabola at that point. So now that I know p is 2, we also know the coordinate for the vertex. So they gave me the vertex. I didn't have to do anything to find that. My h value was 3, and my k value was equal to 4. So with all three components found, I can now just plug them into the equations, going back to the standard form here. This one is opening to the right, so notice that p should have been a positive number, which is what we had. So I'm just going to plug in the three numbers I found here, here, and here. So it's going to be y minus 4 squared, k always goes with y, equals 4 times p, so 8, and x minus h. So there's my standard form of the first parabola. On the next example, I'm going to switch to the black pen again. They told me that the vertex is at 0, 0. So based on that, I know h equals 0, and I know k equals 0. Next, they told me the directrix is at y equals negative 3. So remember that the y equals equations, that makes a horizontal line. So negative 3 means down 3. So here's where the directrix is landing. With those two components filled in, I now need to figure out where the last one lands. So I'm looking at the distance between the vertex and the directrix, and I see that that's a length of 3. So I know, since the vertex is halfway between, that I can go 3 more in the opposite direction, and that will be the location of my focus. So at this point, I know p is either a positive or a negative 3. Let's figure out which one it is based on which direction the parabola is opening. So I don't need those distances in there anymore. So the parabola is going to go towards the focus, or away from the directrix. And if it is opening up, I will again point this out real quick, it's pointing up, so this time it is again a positive value for p. So it's a positive 3 for my p value. The other thing we can do, since we have all of our components labeled now, we can go ahead and write the equation. So I know I'm using the one on the left because it's the up or down opening. Specifically, it's the up opening. So I'm just going to plug in h, p, and k in those spots. So I'm going to have x minus 0 squared equals 4 times p, y minus 0. Now, some things are unnecessary to write in math, like raising something to the first power, multiplying by 1, or adding and subtracting 0. So in this case, when you have zeros for your h or your k values, you don't actually want to write x minus 0. We would simplify this, and we would just call this x squared equals 12 times y. So I'm distributing 12 times y, but the 12 times 0 does nothing. And I'm just getting rid of the minus 0 in there, so we don't need the parentheses anymore. So when the h or the k components are 0, one or the other, you do not need that parentheses to write x minus or y minus the other number. Here's another example. I'll switch back to the black pen for what they gave me. I have a focus at -4, +3, and I have a directrix at y equals, so it's a horizontal line again, y equals -1. So we want to measure the distance between the, well, for the focus and the directrix, we can actually find the one that's halfway between. So since this isn't my vertex, which dot would be exactly an equal distance from both of these? That would be this dot right here. And then I can measure the distance from the vertex to the focus. In this case, that is a length of 2. So I know P is 2 based on that. Again, this time, since my vertex is below the focus, it is opening up again. So that means it is going to be a positive number for my P value. And for my H and K value, we had to find the coordinate for the vertex this time. So my vertex was left 1, 2, 3, 4, and up 1. So H was -4, and K was +1. And so that dot, if I measure the distances, I can see that it's up 2 to the focus or down 2 to the directrix. So again, I'm using the fact that the vertex has to be halfway between to find that third object. With my equation all filled out, this is again the same case we just did on the last example. It's opening up, so P will be positive. So I'm just going to plug in H, P, and K in those spots. So I have X minus, and then since my X coordinate is a -4, when you subtract a negative, the double negatives cancel. So this will be X plus 4 squared. And then I have 4 times P, so this will be 8, and Y minus K. I don't need to do anything else to simplify that one. There aren't any minus zeros, so that one is finished. And let's do one more example here together. On the last example, I'm going to switch to the black pen again for what they gave me. I have a vertex at 3, -1, and they told me which direction it opens, so I know that it's going down, which will help me figure out whether P is positive or negative. In fact, that specifically, let me just write it. That means P is going to be a negative number. And they told me that the focal width is 12. So the formula for the focal width was the absolute value of 4P. So what happens on this is the absolute value of 4P equals 12. Basically, I don't know if 4P equals -12 or if 4P equals +12. That's what we do when we're solving equations with absolute value bars. So it could be the case where P is equal to -3, or it could be the case where P is equal to +3, but this is where the other fact comes back into play. Since I said the opening down statement, that means that P had to be a negative number. So I know out of these two that it has to be this case. So now I have a negative number for P. Now the other thing that it's just done for me is it's told me that the distance I need to go from my vertex to my focus is 3, and that means I could go in the opposite direction to find the directrix. So that would be the shape of my graph. The coordinate for my vertex, my H value was +3, and my K value was -1. Again, on this question, those were actually given to us in the problem. So this is an opening down equation. So again, I'm using the one over here. So I have X minus H, 4P, Y minus K. So I'm going to write X minus 3 in parentheses squared. This time I have a -3, but I'm still multiplying the number by 4. So this will be -12. And then Y minus -1 is Y plus 1. So there's the standard form of my parabola. Some of this you can also do backwards if I give you the equation. I hope you'd also be able to draw the graph from that. But right now we're focusing more on taking the components and creating the equation and graph the other way around. So that's it for the notes. I hope that was helpful. Good luck on the assignment.